Hello and welcome back. Now I explain direct and reverse problems on a planar datum. Consider the coordinate system x and y, and I have the coordinates of the first point. Point I is a noun point, and I know that the direction of the north is parallel to the y-axis of the system. I measure the distance between the points and the azimuth between them, and the goal is to determine the coordinate of the second point, the unknown point j. So this means that from the known coordinate xi and yi, I go directly to determine coordinates of the point j using the distance and azimuth between them. Mathematically, I can write xi, or the x coordinate of the second point or the unknown point, equals the x coordinate of the first point plus L, the distance, the horizontal distance between the point, and sine of the azimuth. And for y coordinate, similarly, I can write y coordinate of the point j equals the y coordinate of the point I plus Lij, or the horizontal distance between the points, and cosine of the azimuth. This is the direct and reverse problem on a plate of data. Now consider 2 points in the same coordinate system. Now this time we have the coordinates of the points and they are known. And if we have these two lines or two directions to the north, the goal is to determine the horizontal distance between the points as well as their azimuth, the direct azimuth, and reverse azimuth. So the problem is that we have the coordinates of the points, and in a reverse problem, we want to determine the azimuth and the distance between them. The distance is simply can be computed from the coordinate based on Pythagoras rules. So if I have the x coordinates of the point j minus the x coordinates of the point I squared plus the y coordinate of the point j and y coordinate of point I squared and square root of some of them. That's a well-known formula in geometry. And for the azimuth, we already know that the azimuth can be determined from the tangent inverse of the ratio, or the distance, the difference between the coordinate of the x coordinate of point j minus the x coordinate of point I over the y coordinate of the point j minus the y coordinate of point I. Also, the reverse azimuth can be determined in a similar way, but in this time we replace the coordinate of point I and j. It means that the right coordinates of the xi minus the coordinates of xj. Or we can determine the reverse azimuth simply based on this formula. Why? Because if I extend the line passing through I and j, it takes this line, and since these two directions of the north are parallel, therefore this angle, this part of this angle, will be the same with the direct azimuth. So the rest of them, which will be this angle, will be 180 degrees. That's all. That's the reverse problem. So we determine the distance between the point and the direct or reverse azimuth between them.